Today we're going on to the last section in 4.1. We're on 4.1.7 on page 224. And today we're going to be talking about flight. How does this even work? How is it that planes fly through the air weighing so much more than the air around it? We're going to talk about this today. So objectives. Apply Bernoulli's principle of flight. Describe how thrust, drag, lift, and weight work in flight. Explain how a plane accelerates. Vocabulary. Drag. The frictional force of air molecules exerted on a flying aircraft. Lift. The force that pushes up an aircraft. Pneumatic device. A device that uses compressed gas to transfer pressure from one point to another. Thrust. The force that pushes an aircraft forward. Interesting things happen to pressure of fluids in motion. Swiss physicist Daniel Bernoulli, 1700 to 1782, studied steady flowing fluids. He determined the relationship of factors such as pressure, speed, and elevation in a moving fluid, and the relationship between compressibility and viscosity as they contribute to the total energy of the system. Viscosity, if you don't know what that term means, it just means the thickness of the liquid. And so water has much less viscosity than molasses would, or pudding. And so fluids can have different levels of thickness, even though they are still considered a fluid. So viscosity is that word that describes the thickness of the fluid. Okay, let's see where we were. When you place your thumb over the end of a garden hose and restrict the flow of water, the water actually moves much faster. Plumbers use large pipes to bring large quantities of water into a house and then increase the velocity of water for the faucets by connecting the larger pipes to smaller pipes. So when you have a lot of water moving in a big area and then it has to be compressed into a smaller area, it creates greater pressure, which forces it to go faster. Bernoulli also found that the faster moving fluids create an area of low pressure. Bernoulli's principle states that the pressure that fluids exert on the surroundings decrease as their speed increases. Liquid flowing through pipes will exert less pressure the faster they flow. As gases flow over and around objects, they exert less pressure on the object than the faster they flow. Have you ever noticed how the shower curtain moves closer to you while you're in the shower? When the shower is running, the curtain pulls inward because the water flowing inside the curtain creates a low pressure in relation to the pressure outside the curtain. The high pressure on the outside pushes the curtain in. Bernoulli's principle is used in the designing aircraft wings. The specific shape is called an airfoil. The air flowing over the upper curved surface of an aircraft wing moves faster than the air beneath the wing. This makes the pressure underneath greater than that on top of the wing. The difference in pressure causes lift, a force that pushes upward on the wing and makes flight possible. Fluid flow principles are also used in designing ships, submarines, streamlined, fuel-efficient cars. So that's pretty amazing that they were able to figure that the curvature of the surface area above versus below creates different pressures that can cause lift. So you have a picture on the bottom, Bernoulli's principle of air. You have low pressure pushing down on the top as the air is moving faster over the top, and a high pressure on the bottom as the air underneath it is moving slower. Because of that high pressure pushing up being greater than the low pressure pushing down, it causes lift and allows the vehicle to come off the ground. Another factor that causes lift is the slant of the wings. According to Newton's third law, the slant of the wings forces air down, and the equal and opposite reaction of force is exerted upon the wing. In addition to lift, 3 other forces are working during flight: gravity or weight, thrust, and drag. Weight works in opposite to lift. If it is greater than the lift, the plane will descend. If the plane begins its flight with too much weight, it will not be able to create enough lift to take off. How does the plane create enough lift to take off? Consider Bernoulli's principle. The speed of the air over the top of the wing has to create extremely low pressure. To increase the speed of air over the wing, the plane has to reach a certain velocity. This is why an airplane speeds down a runway. It continues to accelerate until it creates enough lift to get off the ground. So that's why it has to have a long runway in order to get up off the ground. Otherwise, it's not going to happen. Thrust is generated by engines, and it's the force that pushes the plane forward. Drag works in opposite to thrust and is the friction created by air molecules. Imagine how much drag would be generated if the front of the airplane were a flat square. Too much drag on the plane would prevent its ability to create lift. The plane would never take off. When thrust and drag are equal, the plane is moving at a constant rate. For the plane to speed up, the thrust has to be greater than the drag. So this is why you see planes having a rounded bullet-shaped front or a pointy front going to the back. So all of that air that's being forced at a quick speed is going right up and around it. If it were flat, if it were hitting a flat surface, it would cause a lot of drag and it would cause it to slow down. If you've ever watched drag racing, I don't know if your brothers or dads like car racing, but we used to love watching drag racing growing up. And so what that is, it's like a short sprint of a race. Drag racers are really long, skinny cars that have like two wheels in the front, and then the person sits about halfway back, and then two really big wheels in the back. And what happens is they go really fast, and then they release a parachute, which causes drag. It creates a flat surface area for that air pressure to hit, which slows down the race car. And so it's called a drag race because it's causing drag. So if your airplane had a flat surface in the front, you're not going to be able to go as fast or pick up the velocity needed because that air pressure or that drag is causing too much pressure for you to move forward. Let me make sure I am not reading the same thing over twice. Okay. The motion of an airplane relies on the relationship of these four forces. When all are balanced, the plane cruises at a constant speed. Suppose the pilot wants to maneuver the plane while it is in the air. Consider that when driving on the ground, a driver can move its car from side to side by turning the wheel, or front to back by placing the car in driver reverse. A pilot has different methods to create an unbalanced force and to accelerate. To change the yaw, or left and right movement, the pilot moves a rudder on the tail. To change the pitch, up or down movement, the pilot adjusts the elevators on the tail of the plane. To roll the plane, the pilot moves part of the wing up and part of another wing down. These parts are called ailerons. So if you've ever been to an air show, you see fighter jets can do all kinds of tricks. They can spin in the air and go upside down and do loops and all kinds of things. And all of that has to do with the use of the sections of the wings that can go up and down. So if you have one up and one down, that's going to cause a spin. It has to do with the rudder on the back of the plane, kind of like in a boat, which changes direction. And it has to do with the other part of the tail in the back that goes up and down in order to create it to go up or to go down. So all of those things have to do with air distribution. How is the air flowing over the plane? At what speed? Where is the high pressure versus the low pressure in order to change direction, keep it up, or bring it down to the ground? Pneumatic devices also make the use of Pascal's principle and Bernoulli's principle. Pneumatic devices are devices that compress gas to transfer pressure from one point to another. Pneumatic tools are connected with hoses to compressed air tanks. When a valve is opened at the end of the hose, the force of the compressed air moving from a high pressure to a low pressure provides the energy needed to make the tools work. Examples include rock drills, pavement breakers, and blast cleaners. So with Pascal's, we were talking about hydraulic engines. And so that's using a liquid or fluid in order to create the pressure to make forward movement. In Pascal's, we're using gas. And so you have gas compressed in an area that is causing higher pressure, which causes a tool to work. And so like air compressors, if you fill up a tire at a gas station, or if your dad has an air compressor, that is compressed air. It's a pneumatic device that when you turn the valve, because of the high pressure of the gas, it shoots the gas out at a really high speed. You have pneumatic drills, lots of tools that run off of an air compressor. And so that compressed air causes force that is pushed through tubes when a button or a valve is pushed, and then creates energy in order for the tools to work. So it's all based on gas pressure. Some questions to answer for today. What is Bernoulli's principle? How does Bernoulli's principle apply to flight? Explain how lift, weight, thrust, and drag exert force on an airplane. What creates acceleration or a change in velocity? Describe how a plane accelerates or changes direction using the terms yaw, pitch, and roll. Now you can apply this as well to not only airplanes, but things like hang gliders, or even if you've ever seen, this is something you can look up. So hang gliding is really cool, and that's basically where you jump off a mountain or some very high area, and you have a triangular kite, basically, that you hang underneath, and there's usually a harness that you strap to, so you're laying flat, holding onto handles, and you have this basically triangular kite above you, and you are gliding through the air, and you can go for really long distances, and it all has to do with gravity pulling you down to the surface, so you will eventually end up on the ground, but also airflow, and how you maneuver that hang glider to keep yourself afloat, to change directions. But because that high pressure, you have a high pressure on the bottom, the air flowing on the bottom, and a lower pressure over the top, it's creating stability in order for you to glide through the air and not just plummet to the ground. And because you have surface area that is hitting that air pressure, it keeps you afloat. Now, if that hang glider were to fold in half, you would then plummet to the earth because you don't have that surface tension anymore. Something else that's really cool that I would encourage you to look up is something like a hang glider, but it's actually an outfit that people can wear, extremists, if you like extreme sports. It's almost like a flying squirrel outfit. So it takes the concepts of a flying squirrel, which flying squirrels don't really fly, they glide, and they have a membrane that connects from their hand to their foot. So when they go out in a starfish position, they have these long membranes or skin that creates a larger surface area, so when they jump off a tree, they can glide down to where they need to go. And so they have made outfits, like a bodysuit that you can put on that has that same dynamic where you can, again, jump off the side of a mountain and glide simply by wearing this outfit because of your surface area is increased. And it's amazing to watch the people who are professionals at this because you can glide through a mountain range, and then if you close your arms down, what do you think is going to happen? You're going to go at a much faster pace because your density, your volume is greater than that of the air, and so you're going to start picking up speed towards the ground really fast. But then as soon as you put your arms back out again and flatten out, you've created that surface area again that high pressure pushing up can grasp, and then you go to floating again. It's a lot more tricky and dangerous than it sounds, but it's amazing to watch. So see if you can find some videos on that to see how this works, because it's really fascinating. I would not have wanted to be the person to test out how those outfits work. Hopefully they do it inside one of those air pressure chambers rather than trying off a mountain. All right. So next time we're going to be going on to 4.2, which is a new section, and we're going to be talking about energy. And so work and energy, where we get our energy from, the transfer of energy, hovercrafts, all kinds of things like that having to do with energy. I will see you then.